C++ allows us to use pointers, but in doing so, we lose some ability to use virtual functions in classes. Luckily, there's a workaround this issue by designating base class functions with the keyword virtual. This indicates to the compiler that the base class function may be overridden by a function of the same name in the derived class. Let's look at an example of function override and how that might fail with pointer objects. So I'll define a class mammal, open curly braces, we'll have a private variable string print statement, and it will be mammals can give direct birth with a public print function, so we can see or we can inspect its behavior. For the class mammal, we'll print the statement we just defined. Oops, that was our void print me. So the function void print me is going to print out this line, mammal print statement, and then a new line. I'm going to close this class with a semicolon, and I'm going to define a class that inherits from mammal, and all members of mammal retain their original access. So private has its own print statement equals a new animal, and a public function which is same as what we defined for the class mammal. Now what I'm going to do, just to see how all this behavior works, is define a object bat from the class bat, and this will demonstrate function overriding, which is that bat calling the primi function will print this, the bat's version of the primi function and print statement. If I run it, it prints mammal. It prints, rather it should be bat, not mammal. Prints bat, a new animal. Now let's say we wanted to define a pointer object that points to, so a mammal object that points to the bat, and I have pointer to bat is calling the print me function. And let's see what that prints out. So what you can see here is that when we define a class mammal that points to the bat, it will print the function defined in the class mammal rather than what the bat is, the values that the bat is going to print out. So typically this is not a behavior that we're expecting. Rather, we're hoping that this pointer is going to return and retrieve and behave the same way that the bat object is. So in order to do that, in order to get the print statement that bat was meant to print out, we can add the keyword virtual to the mammal function. And this tells the compiler in the system that when a pointer is defined not to point to what the class mammal has, but rather to point to the function that is within the actual bat class. And so this pointer is going to be overwritten by the bat class. If you run that, we can see that the pointer now points to the function within bat, and it formalizes our intention that when a class is derived from mammal, then whatever that class contains, the functions in that class overrides the base class. So this just says formally